Please use your printed notes or write down the warm-up questions from the note handout from Google Classroom so you can work out the problems and then check your answers on the bottom of the page. Today's lesson's essential question is, how can you use the unit circle to define the trigonometric functions of an angle? Well, first let's talk about a unit circle. A unit circle means that the radius of a circle is 1 unit long. Let theta be an angle in standard position with xy, a point on the terminal side of theta, and r equals the square root of x squared plus y squared, which does not equal 0. The 6 trigonometric functions of theta are defined as shown. Sine theta is y over r. Cosecant theta is the reciprocal, which is r over y, where y does not equal 0. Cosine theta is x over r, and its reciprocal function secant theta is r over x, and again x cannot equal to 0. And tangent theta is y over x, x cannot equal 0, and cotangent theta is x over y, and y can't equal 0. We are not stating that the radius can't equal 0, even though the radius is in the denominator, because it wouldn't make sense to have a circle with a radius 0, and the radius is a distance, so it's never going to equal to 0. In case of a unit circle, the radius would equal to 1. Before we look at the diagram on the right hand side, I would like to create a diagram with the angle or the order pair x and y actually being in quadrant 1. So let us make a diagram where our theta has a terminal side in quadrant 1. So the angle theta would be here, and the order pair x and y would be here. So if I create a right triangle, I know that this distance would represent the y coordinate, because that's the length from 0 to the order pair y. It's a vertical distance. And the horizontal distance would be represented by the x coordinate, because that's the distance from the y-axis to the x coordinate of the point. So if we are looking at this particular triangle right here that I created in blue, we also know that the hypotenuse of the triangle would equal to the radius, and the right angle would actually be a right angle between the x-axis and the little vertical segment that represents the y coordinate. So if we say that r is equal to the square root of x squared plus y squared, this statement comes from the Pythagorean theorem, because I know that the hypotenuse r squared would equal to x squared plus y squared. But if I want to have just the length of the hypotenuse, then I would have to take the square root of both sides. And then I would land onto the expression that it was in the definition, r equals the square root of x squared plus y squared. If you notice that the diagram I just made, my ordered pair xy is both positive values, because the x coordinate in the coordinate plane is going to be a positive in quadrant 1, as well as the y coordinate is also going to be a positive number in quadrant 1. Now, how would that look like if we are looking at the diagram that the book actually, or the lesson actually gives us? So in this diagram, I would create a right triangle right here, where this part here is the hypotenuse, which is the radius that they had labeled on the left-hand side. So let me go ahead and rewrite this. They labeled it here, but that would represent the radius right here. And then I would have my x coordinate being a negative value, and the y coordinate, since I'm in quadrant 2, it would be a positive value. So you can see that it depends on the value of the trigonometric ratio being positive or negative. It depends on where the terminal side lands, which quadrant it lands in, because that's where your ordered pair xy is going to be in. So for example, in this case, we are in quadrant 2. So in quadrant 2, our x would be negative and our y would be positive. So let me go ahead and put an x over here that I didn't put. So x would be negative. Now, if you're looking at the diagram that I made in green, you can also see that the right angle is going to be over here. And what I'm using to calculate the trigonometric ratios is actually not angle theta, but this yellow angle right here, which we are going to call the reference angle for angle theta. So the yellow angle is going to be called the reference angle for the green angle, the light green angle theta. If you printed your notes, you will be able to see this unit circle. That is a blank unit circle that I would like everyone to have in front of them before we start filling them in. So first we are going to start with making our special right triangles. So the first special right triangle is our 30, 60, and 90 special right triangle. In the first triangle, we'll write the general formulas. So A represents the shorter leg, and then A times the square root of 3 represents the longer leg, and then the hypotenuse is twice A. Now, what will this look like if I am drawing a special right triangle where the shortest leg is 1? So if the shortest leg is 1, then the longer leg is square root 3 times 1, or just square root 3, and the hypotenuse is going to be 2 units long. So now we are going to move to the last one. And in the last one, since the hypotenuse in the triangle is going to be the radius, I would like to make the radius to be 1 unit long. So from here, I can calculate the shorter leg, which is going to be a half of the hypotenuse. And last, the longer leg is going to be square root 3 times 1/2. In other words, the square root 3 divided by 2, or half of square root 3. So let us go ahead and put in the angles in these two, 30 degrees and 60 degrees, and 30 degrees and 60 degrees. We are going to use these right triangles, these special right triangles, to develop the unit circle. So the second set of special right triangles are 45, 45, 90. And again, I'm going to fill in every one of these little triangles. And 45, 45, and 90. And we'll go through the same process. So if one leg is a unit long, since a 45, 45, 90 triangle is, right triangle is an isosceles triangle, the other side is also going to be the other leg a unit long, and a times square root 2 if I have the hypotenuse is square root 2 times the leg. And then I'm going to move to the second triangle where A is going to be 1. So each side will have a side length of, each leg will have a length of 1 unit. And the hypotenuse is 1 times square root 2, or just square root 2. And then for the last one, again, I'm going to use the hypotenuse to be the radius. So I want that to be a 1 unit long. 1 unit length. So that means my side length is going to be 1 divided by square root 2. So if I rationalize the denominator by multiplying by square root 2 over square root 2, we are going to have an answer of square root 2 over 2. Square root 2 over 2 and square root 2 over 2 for the length of the legs. These special right triangles will be important to us later as we develop the unit circle. But first, let's go ahead and talk about angle measures. So for the angle measures, I'm going to use blue color. So this here is my 0 degree. I know that this is a straight angle, so at a straight angle, I will have 180 degrees right here. And if I go all the way around the circle, I know I am going to land on 360 degrees. So I also know that a half circle is 90 degrees. And if I pass 180 degrees, which is right here, pass it by 90 degrees, I will get 270 degrees. So now let's go to smaller angle measures. For example, the half of 90, which will be our 45 degrees. Then if we pass the 90-degree angle by another half of a quadrant, then we land on 90 plus 45. So that's going to give us 135 degrees. Then we keep moving, and so we are going to add 45 degrees to our 180 degrees. So we are going to land on 225 degrees. And then from 270, again, we are going to add 45 degrees. So we are going to land on 315 degrees. So we just completed our circle going by 45-degree measures. So 0, 45, 90, 135, 180, 225, 270, and 315. So all these measurements are used because we have one of our special right triangle that is very easy to calculate trigonometric ratios from, and that is our 45, 45, 90 triangles. So now we are going to go by smaller measurements. So we are going to look at our second special right triangle, and we notice that the smallest angle here is 30 degrees. So let's go ahead and go by 30 degrees. So if here is our 0 degrees, then the first angle here is going to be 30 degrees. Then 2 times 30 is going to give us 60 degrees. Then 3 times 30 gives us that 90. Then 4 times 30 is going to give us 120 degrees. And then we'll move on 5 times 30, which will give us 150 degrees. Then 6 times 30 is 180. 7 times 30 is our 210 degrees. And then 8 times 30 is our 240 degrees. 9 times 30 is 270. 10 times 30 gives us the 300 degrees. And then we go 11 times 30, which gives us the 330 degree measure. Now you can see how these are multiples of 30 degrees, but if I'm looking at, for example, the angle here 60, I could also go by multiples of 60. So 60, 120, 180, 240, 300, and 360. So all these angles in the unit circle come from the special right triangles, and again they are the 45, the 90-degree angles, the 30-degree angles, and the 60-degree angles. So this will be the end of our video 1, and then I'm going to move on to part 2. As you can see, the unit circle is going to take us quite a while to develop.